Number 62. Determine the formal charge of each element in the following. And then they give us A through D. Okay, so this one is pretty simple, but you guys need to know two things in order to answer formal charge questions. The first thing that you need to know for every formal charge is you need to know how to write the Lewis structure. So if you think that you aren't strong in drawing your Lewis structures, that's okay. Just go back to, I think the questions start at 40 for this chapter, and I do all Lewis structures just for you guys. So just go back to those questions if you do need the help. I'm going to assume that since we're at, number 62, we know how to do Lewis structures. So that's the first part. And then you just tie in the Lewis structure with the formal charge formula. Now, there's a formula that they give you in the textbook, however, I think that's a little messy, and I like to give the formal charge formula like this. I think that this one is much easier, and I'll show you how easy it is when we actually go through the questions. So that's all you need. You just need to know how to do your Lewis structures, and you just need to memorize the formula. Okay, so let's get started. So for A, they tell me that it's HCl. So the first thing that you're always going to do is you're going to draw the Lewis structure. So that's step number 1. So now if you want, you could pause the video and try to do the Lewis structure for HCl by yourself and see if it matches my answer. So here we go. I'm just going to give the Lewis structure because I am assuming that we know how to do that. So HCl will look like this. H will be single bound to chlorine, and chlorine has 6 valence electrons. Easy as that. The first part is done. Now we will do the formal charge formula for each element. They want each element. So we have to do it for hydrogen and chlorine. And the formal charge formula is for atoms. It's not for the overall formula, it's for the individual atoms. So let's look at hydrogen first. So I'm just going to put down over here, we'll say formal charge FC for hydrogen. So the first thing is always you're going to find the valence electrons for that atom, and that will always be found on the periodic table. So hydrogen on the periodic table will always have 1 valence electron. So that's the first number, 1. So it's the valence electrons minus now the number of bonds you see that is with that atom. So if I look at hydrogen, how many bonds is hydrogen bound to? Well, hydrogen's only bound to this 1 single bond. So how many number of bonds do you see? Just 1. So it would be 1 minus 1. And then you subtract by the number of quote-unquote dots, right? And those are just lone electrons. Those are the dots that you see. So for hydrogen, are there any dots that you see? No, right? If I scan hydrogen, there's no dots here. There's no lone electrons. So this would be minus 0. And now we just do the math. So 1 minus 0 is 0. And that would be the formal charge for hydrogen. Now let's move on. Let's do chlorine. I'll put chlorine over here, I guess. So formal charge for Cl. Same type of procedure. Start with the valence electrons, which is on the periodic table. Chlorine's over here. It has 7. So you'll start with 7 minus number of bonds that you see for chlorine. So chlorine, Cl, if I look over, it just has the 1 bond. So that would be minus 1. And now, number of dots, or lone electrons, how many dots do you see on chlorine? Look at all these, right? So how many total? 1, 2, 3, 4, 5, 6. So you would subtract minus 6. So 7 minus 1 is 6. 6 minus 6 is 0. So both of these, both hydrogen and chlorine, have a formal charge of 0. And what do the formal charges really tell you? They tell you if the compound is stable. So I'm just going to say says if compound is a stable compound. The less charges, the better. So since both hydrogen and chlorine have 0 charge, they have no charge, HCl is it's a pretty stable compound. And we see it all the time. You'll use it in your labs. So HCl is a stable molecule. So A is done. So now let's do the same thing with B and pick up the pace, right? So with B, we have CF4. You could pause the video, try to figure out the Lewis structure, and then match it with mine. So CF4 would have carbon in the middle, surrounded by 4 fluorines. And each of these fluorines would have 6 dots. Now, if you've noticed, all the fluorines look identical. Each fluorine has only the 1 bond and the 6 lone electrons. So if you do the formal charge for one fluorine, you will know the formal charge for every fluorine because they look exactly the same. If you can spot out atoms that look exactly the same in a compound, the formal charge will be exactly the same for all those atoms. So in this case, I'm only going to do the formal charge for carbon and the formal charge for fluorine, but whatever I figure out the formal charge for the fluorine, it's going to be for every single one. So let's do carbon first. Carbon, we start with valence electrons, which is on the periodic table. Carbon is over here, it has 4. So it'd be 4 minus. Now, how many bonds does the carbon have? So now here, this carbon has 1, 2, 3, 4 bonds that are attached to the carbon. So that would be minus 4. How many dots does carbon have, or how many lone electrons does it have? Well, if you look at the carbon, does it have any dots? No, I don't see any dots here, right? I just put those in just to show you guys, but it doesn't have any dots, so minus 0. So the formal charge of carbon would be 0 if you did the math. Now let's do it for fluorine. Fluorine's over here. It has 7 valence electrons. So we start off with 7 minus, how many bonds does a fluorine have? Let's do the one on the right-hand side. How many bonds is directly bound to that fluorine? In this case, there's only 1 bond, right? I can't classify all of these because those are not attached to this fluorine. This fluorine only has that 1 bond attached to it. So this would only be minus 1. And now, for the same fluorine, how many dots does it have? 1, 2, 3, 4, 5, 6. So you subtract 6, and this would be 0, which means that the formal charge for this fluorine is 0, the formal charge for this fluorine is 0, the formal charge for this fluorine is 0, and the same thing for this fluorine up top here. They're all 0 because they're all the same. So that is the answer for B. So we have 2 compounds that had no charges in them, which means that they're pretty stable. Next, I'm going to erase this just so that we have some room. And let's get to it. So now we're on C, PCl3. So once again, you can pause the video if you want to try your Lewis structures. But you should come up with a phosphorus in the middle, surrounded by 3 chlorines. Each chlorine has 6 valence electrons. And the phosphorus will have 1 pair, so you'll have 2 dots. So, looks like for this one, all the chlorines are exactly the same. Each chlorine has 6 valence electrons, 6 lone electrons, 3 pairs, and 1 bond. So if you find out what the formal charge for one chlorine is, you'll know for the other ones because they look exactly identical. And then we just got to figure out the phosphorus one. So I'm going to just put over here, we'll say formal charge of P, and then we'll do formal charge of Cl. So let's do phosphorus first. Always start with your valence electrons, which is on the periodic table. So for phosphorus, there's 5 valence electrons. So I'll say 5. Minus, how many bonds does the phosphorus have? Well, it has 1, 2, 3. So 5 minus 3 minus, how many lone electrons does phosphorus have? Oh, it has 1, 2. So this would be 5 minus 3 minus 2, which is 0. Another neutral atom. Stable. Now let's do it for one chlorine. Let's do it for the chlorine on the bottom here. So chlorine's valence electrons is 7. So that would be 7 minus. How many bonds does this chlorine have? Well, now I'm just looking at this chlorine, so I can only take this bond. I can't take these other bonds because they're not bound to the single chlorine. So this would be only one bond. Minus, how many dots does this chlorine have? 1, 2, 3, 4, 5, 6. So minus 6. And that would be 0. So another stable compound, which means that the formal charges for all the chlorines would be 0. Formal charge for this chlorine is 0, and the formal charge for this chlorine is 0. Perfect. Super stable, all zeros. Last but not least, let's do PF5. I'm just going to draw it over here because I have a little bit more room. So you can pause the video again, but you should get a phosphorus that now has 5 fluorines around it. So I'll say 1, 2, 3. We'll put the other F here, other F here. And each fluorine should have 3 pairs of lone electrons or 6 total lone electrons to make it happy if you did the Lewis structure properly. And in this case, the phosphorus does not have any lone electrons inside. Okay, so same exact thing here. I see that I have 5 fluorines, 1, 2, 3, 4, 5, but they're all exactly the same. Each one of them has only one bond and the 3 lone pairs. So if I can figure out the formal charge for one of them, I can figure out the formal charge for all of them. So we'll say formal charge of phosphorus and then formal charge of fluorine. Okay, so let's start with phosphorus. Valence electrons come first. Phosphorus has 5. So it would be 5 minus. Now, how many bonds does phosphorus have? 1, 2, 3, 4, 5. So that's 5 minus 5. Minus, how many dots does phosphorus have? Well, now I look over here, and there's no dots around here, right? They're all bonds. So it'd be minus 0. So 0 would be the answer. Phosphorus would have a 0 charge. Pretty stable. And then let's do it for one fluorine. We'll do this fluorine over here. So fluorine has a valence electron of 7. So you start off with 7. So 7 minus. How many bonds does fluorine have? Now in this case, you can only look at the fluorine. So fluorine is only bound to one bond. So that would be minus 1. And then minus, how many dots? 1, 2, 3, 4, 5, 6. So minus 6. And you get 0, which means that all of these, formal charge for this is 0, formal charge for this fluorine is 0, formal charge for this fluorine is 0, formal charge for this fluorine is 0, because they're all the same. So that's it. So for all of these, every single formal charge for each element was 0. How amazing is that? So this one is technically done. So all you had to do is just circle the numbers, and they were all 0 in this case. But we should be able to kind of bring together some similarities here. The thing is that remember in chapter 1 or 2 when we said that groups have very similar properties, right? So the halogen group has very similar properties. The chalcogen group has similar properties. The noble gas group has very similar properties. So look here. Look at this chlorine, right? This chlorine has one bond and 3 lone pairs. And chlorine's over here. As opposed to fluorine, look at this fluorine. It has one bond and 3 lone pairs. And that's over here. Do you see the similarities? It doesn't matter what halogen you have. If the halogen, whether it's fluorine, chlorine, bromine, or iodine, if it has one bond, like we've seen in all of these halogens, if it has one bond and 3 lone pairs, right? 1, 2, 3, 4, 5, 6, or 6 lone electrons, it will always be a formal charge of 0. It will always be stable. That's what we kind of have to take away from this exercise. So yeah, we could do the math, but understand that groups have these similar properties. So if you know that one bond and 3 lone pairs would be, neutral for fluorine, it's going to be neutral for chlorine because it's in the same group. And that's the takeaway from this. All right? So hopefully this helped, guys. Let me know in the comments what you thought. If you still need a little bit more practice with formal charge, I got you. We're going to be doing number 63 together, so you can just hang tight. If you're on the playlist, I'll see you in 5 seconds. And have an awesome day. Keep studying hard. You guys got this.